Is it true that there are no stupid questions? Is there anything that we learn through our university engineering degree that translate directly to becoming a full-fledged engineer? We're going to cover this topic off as part of today's episode, so please stay tuned.
This is the Engineering IRL podcast, a place for engineers in the real world. We try to break down engineering concepts and figure out how to apply them to real life. Let's become better problem solvers, better engineers. I am your host, Andrew Sario. Let's begin.
Today's episode is brought to you by our friends at the Computer Science Software Engineering College Courses Review podcast. Andres Arriaga submitted this question. Hopefully you enjoy this one. And if you want to know how to be part of the next episode or have your question answered, head to www.sariodev.com/engineeringirl. There's a form at the bottom of the page there where you can submit your questions. And if you haven't listened to that podcast, please check it out. I'll leave a link in the description below. Hello everyone, and welcome to the Sario Dev Show, Engineering IRL, where I take you through engineering concepts and teach you how to apply them in real life. This is revision 29, so we're doing pretty good, keeping up the episodes here. And today's topic is going to be what translates from being an engineering student to becoming a full-fledged engineer. And now this question, obviously you can infer a lot, and there'll be some things that will apply to any job. This is just going from student to the job. But what I'll try to do is focus on if you're an engineering student to becoming a full-fledged engineer. So firstly, let's start off with maybe a key difference. One of the differences that you'll find between studying engineering versus doing actual engineering is when I finished my course, for example, and it was all done, there's this area in your head where in theory you should always be studying, you should always be preparing for the next subject so that you can perform better, but it's kind of arbitrary. Like you don't need to finish your degree with a certain mark, right? P's get degrees. You only need to complete it to a certain level, and then the rest is kind of up to you. The harder you work, obviously the higher the grade you can get. But because of this paradigm, you always know it could be better. So you always know, even if you're on holidays, I should probably be studying or preparing or something like that. Because at the end of the day, you're going to have to perform for a test. You're going to have to prove your knowledge. And when you come into becoming a real engineer, you don't need to keep proving your knowledge. What you prove is through the results of the project and the results of your work. So if your work is successful and your project is successful, there's no specific date where you have to prove you have these X amount of knowledge, right? It's locked into the project. So there is no feeling of, I need to just I need to be holding as much knowledge as possible at a certain point in time. So that's good. But there are a lot of parallels. And a lot of the parallels will be with how you treat your subjects. And for each of your subjects, you can look at those as individual little projects. Or you can look at the entire degree as a whole project. There's a lot of ways to skin this, but the whole purpose is saying, from a technical standpoint, I think it's best what I found the most useful type of work that I did at university that came across in the workforce is project work. You work with teams and all that sort of stuff, all that good stuff, but really it's the nature of the work, right? So what proves that you have done and researched the knowledge? No one's going to sit there and test you, hey, what's the answer to page this? Or if you calculate this, what's the answer? There's no test. If your project works, your project works. And for some people, that's a lot of pressure because obviously, you get to the end, you do your project, your project doesn't work. You're locked in. There is no, I might perform really well or whatever. On the flip side, no one's checking how much research you've done. If your project's good, you could have done no research. And that's kind of how it is in the real world. You won't get away with it for long, right? But at the end of the day, you're solving a problem for a specific customer that actually has a need, right? This is not to get as high a grade as possible. There is a need for a customer that needs to be filled, and contractually you have to deliver it. And because that's the case, if you deliver it, they don't look in to see the method that you use, to see the research that you use, to see if you can remember X, Y, or Z. If the project works, the project works. And typically for the project to work, it means you have put in that same research anyways. So there's no poo-pooing on the research or doing the work or the method. It's not saying that there's a shortcut and you can hide it. It's saying that the importance of on your method, proving your method, isn't as important as proving the solution. And maybe, every uni is different and they align to different things. But at the end of the day, for the incentive for universities, they have to prove that you have that knowledge at the point that they've taught it to you. So a test is necessary to prove that. A test is necessary to prove that they have passed on the knowledge to you. And so that comes with the pressure of, doing well in tests and memorizing well and all these sort of things. A key skill that happens is communication. Definitely communication skills matter, and the way you approach problems. There's in the workforce, there's not many cases where you can just be really good at memorizing math stuff and being able to solve math problems, because it doesn't matter how good you are at solving problems if you can't tell anyone about it, right? So communication becomes key, because sometimes there may be several solutions. So it doesn't matter how well you can execute on one solution. That is a factor, but that's not the only factor, right? And when you're testing at university and you're doing all your tests, you're trying to perform well in these subjects, really that's individually about you executing a solution well. Whereas in the workforce, in an engineering project, there might be 3 or 4 ways, or 3 or 4 or 5 or 6 solutions that are all possible. And the assumption is that you will have the capability to execute it. And where the skill and the experience comes in is the decisions on which solution to take and why. Why did you choose this solution over the other solution? And justifying it, not the execution of performing it, right? Not the execution itself. Obviously, if you can't execute it, then that is a problem, but I'm highlighting here the differences. So I would say definitely focus on projects, subjects with projects, more so than the testing ones. Like, obviously you have to get your grades, but don't beat yourself up in terms of how you are or how you may fare as an engineer based on test results. Because I can tell you the number one thing that no one asks is, hey, you provided this really cool engineering solution, but what was your GPA? What was your score? No one cares. Like, some people that have really, 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 really high GPAs, sometimes their solution is never, ever, ever, ever gone with. Sometimes it's not, because it doesn't directly correlate to being the best decision. Experience matters. I mean, it's a positive indicator, right? If you do good, then you can be diligent. But some scenarios, and depending what type of engineer you want to be, creativity is necessary. Working on the fly is necessary. Coming up with actual practical solutions is necessary. Sometimes, this is an interesting one. In a university setting, you're looking for the optimal solution, typically. In an engineering real-world solution, in theory, in concept, obviously, you're looking for the most optimal solution. But sometimes the solution that works is the one that goes in. If it's going to take an additional 3 weeks of work or additional equipment that's just not in the budget for the optimal solution doesn't get selected, right? Things are easily over-engineered, and a lot of young engineers tend to over-engineer their solutions. Now that's something to look out for. If you're so let's say you finish your degree, or you're a young intern, you're coming into the workplace and you want to set a good impression, or you're worried about if I mess up, will I get in trouble, for example. And what I'll say with this is, when you're hired as an intern or a grad, you're not hired because of your skills to do the job. You're hired for your potential to eventually do those jobs, right? Also, you're cheaper labor. And so the expectation on you to execute at a level of a project engineer actually is non-existent. And to be honest, when you hire, when a project engineer goes from one company to the next, they still have to be trained, even though they're an experienced engineer. They still have to be trained. So what could they expect of someone with no experience? Not much. The only times you should, unless, obviously you're in a bad company or something like that, or have bad management, really, the only frustration should be your inability or ineffectiveness to work in a team and to work with others. That is the more likely scenario that someone will be upset with you or not happy with your work. You just didn't do it. You didn't have the diligence, or, and this is a key one, not asking when you don't know, right? Say they go, oh, here's 1 week to do this job. It'll probably take them 3 hours, but they don't have those 3 hours. They give you a week, knowing you're new and, it might take a little while. If you have an issue with doing it and you get to the last part of the week and they ask you, how did you go? And you say, oh, I got stuck at this and it's something way early. Or you did a week's worth of work and it was just the wrong thing and you didn't ask a question, that is frustrating. You ask it early, you get the clarification you need, and the clarification questions that you ask, because obviously there's one fear, oh, I'm asking too many stupid questions. But if you've actually taken the time to look at the task, then your questions have a certain context to them that an engineer will go, okay, he's looked at it a little bit, he's a bit confused here, here's the clarification. You're not asking a question that someone had never looked at it before. So if you sit there and ask heaps of questions, but you didn't even start, those are the quote-unquote dumb questions that get frustrating. It's not because of a question's being smart or dumb. Trust me, there are many engineers there that just learn on the job, right? There's a lot of dumb stuff that happens, a lot of obviously smart stuff that happens, but that whole there's no dumb questions is more about what's more important is to ask contextual questions as if you were someone that had attempted to start the problem. Okay, there's a difference between, I'm going to go with a simple task of just like unpacking a desk. If you're asking general questions about how you unpack a desk, and where is the desk, and do you want me to do it now, and did you mean this location, like that's whatever, but that that builds up over time as questions that you go, have you started or what, right? If you're asking those questions, those are not stupid questions, but they're proving that you are not coming from a context of starting the task, versus, hey, I've moved the first 2 items, but it looks like the third one is stuck or doesn't fit or something like that. Especially if it's your first time, man. Ask the questions. Seriously, if you're doing the real work, then your questions will be contextual and there will be no problems with asking as many questions as possible. It also shows them that you're interested, you're active, and you're thinking about your work and you show some care. And then what should happen in theory is the next time you do a task like that or similar, you are not asking those exact same questions, because you've learned, right? You're getting more experience, you've learned. You may ask the question of, well, in that scenario we did this, and in this scenario you've asked me to do this. How do you know when you're doing one solution or the other? Why are we doing this task this time and different the other? And don't question, ask the question, but don't, there's some questions where you come off as if like you're trying to redesign what they're doing and all they need you to do is do the task. If you're coming from a place of, I'm going to do the task and I've done it the way you've asked, I just want to know why it was different this time than the other time. And that's intriguing. You go, well, the engineer might say, well, I made this decision because typically in this scenario it's one way and in another scenario it's another way. And that's perfectly fine, right? There's a difference between saying, why did you design it that way? Or that looks stupid. So it's easy enough you got to ask the questions. You have to be involved. In university, you get your curriculum. You don't even have to talk to a professor or anyone. You don't have to work well with another teammate. If you kill the test and you do everything well and you work within your own self and meet the grade, you're done, right? Your syllabus is kind of like your specification from a customer. And as long as you meet that, you pass. But in the real world, to meet that specification, you'll require talking with your customer, talking with your manager, talking with your team. And that's one project. And another thing to consider that's different is you may feel like, oh, you study multiple subjects, right? So you have to balance all the knowledge of these different subjects. Well, in the real world, it's not rare for an engineer to have to juggle multiple projects. Now, the difference between juggling multiple projects and juggling multiple subjects is at the beginning of the semester, you could be juggling 4 or 5 or 6 subjects, right? But they're all starting from week 1 at the same time. Week 1's the same time. So they're at the same phase of said project. Now in a company where you're working as an engineer, each project could be at a different stage. One's week 12, 2 is in week 5, 4 are in week 1. So then you have to balance the priorities of each project and then also balance the stage that each project is at. So there's a lot more juggling and a lot more balance. And also, it's not about one solution. Typically, you're going to have to come up with multiple solutions for the same problem, weigh up the pros and cons to prove that you've come from an engineering perspective and worried about all the things. And another thing you almost never worry about with assignments is the safety factor, right? Proving safety. You're normally thinking about the technical and the time the scheduling and the technical aspects. And that's what you learn in university. But the budgeting, safety, managing customer expectations, managing red tape, managing politics, managing your relationship with project managers, and managing your relationship with other engineers is a non-factor. Because in university, all you're doing is chasing your individual grade, right? It's kind of like, if someone is going to, like, if your subject continued without you, even after you had failed, you restart. If you fail a subject, you restart. You do the subject again, you go from week 1 again. If you fail an engineering project, all you do is cause a delay. Your company pays some fines, contractual fines, whatever your contract dictates. There could be media involved and things like that, depending on the scale at which you're doing the project. But the project goes on. It must be done. You maybe gain another 3 weeks, not the entire project duration. So it's completely different. You don't have the anxiety, pressure of testing and all that sort of stuff and trying to, absorb all this knowledge and hold it for a period of time. That part is definitely easier in the engineering world. But in the engineering, when you become an engineer, you're going to be cycling through information much faster. In, out, in, out, in, out. And there's 2 ways. If you're going to be very vertical, so you're going to be a full-on expert in one area, you can be very successful that way. And it means you know one area super well, super deeply. You never have this test feeling because you just know this one topic really well. It is then the balancing of the projects. And then also if you're like a project engineer, you're working on different types of projects they use different technologies. You're learning all the time. Methodologies change. Standards change. You almost never have to read the standards in university. You might refer to it and they might have some subjects referring to it. But when a contract just says, your design is like this, you agree on all the requirements, then there's a line that says, and complies with this standard. All components and all aspects of your solution complies with standard X, Y, or Z. I haven't memorized standard X, Y, or Z, but you still need a methodology of being able to read through it, check it, and have some traceability with that. So some skills. So I'm going to quickly jump to some skills that you should kind of keep and retain. 1, your documentation skills, especially early on, is hella important. You should be able to write some good reports from going through uni, and that's a big way you can help all your engineers. Technical drawing, if you have that ability, I think it's a very good ability to have. It's not saying you have to be able to draw CAD drawings to scale and do 3D modeling, but you need to be able to articulate the solutions through a drawing. High-level drawings, architectures, and you need to understand what you're communicating. Which brings me to communication skills. That needs to be super high. And, you do some communication subjects in university and they're super lame, but etiquette matters, articulation matters, and understanding how to to build in traceability to your emails. Your email trail is an excellent way, and you might have like a project management tool like Jira or something for more agile development, but every communication that you put in email is documentation, right? That follows some sort of correspondence. I checked with this person, then I sent it here, and this is how we got here. In university, at the end of a subject, you're never at the end and you go, okay, how did I get here? I mean, you might, but once you finish the subject, boom, flush it in the toilet, you're done. Burn the papers, burn the books. Okay, obviously unsell them to some other student. Burn the books, you're done with it. Throw it in the bin, it's out. You flush it out. Here, 2 years later or a year later, you may need to refer to it. So you need to understand how you even came to the same decisions that you did, right? So there's a few differences, okay? But there's a lot of things you can take away, and there are a lot of parallels and a lot of ways at looking at the same thing. But it's exciting. For me, when I went from studying and I started interning as an engineer, I knew I wanted to be a full-fledged engineer ASAP. It was so good, right? And even if you're doing documentation or the job's not perfect or whatever, I mean, when you're doing the job, at the end of the day, you're going from a requirements piece of paper to design, to work, nutting all that out, to doing testing, to doing all sorts of different layers until you finally come to a solution that's solving a real world problem. It may not be a big problem, but you've gone from paper to solving a problem, and that's out there, right? Your design, your input, your efforts, your work. And if you're working on big scale stuff or industry stuff, I mean, it could be there for years, a decade. I've got stuff that's been put in, and 100%, 8 years later, it's still there. It's running. If you've been following the podcast for a while, you know that I'm in the power generation industry. A lot of power stations have my equipment that I've put in, or my designs that I've put in, and I'm really proud of that. Okay, and if I had to compare that to university, when I say, well, I was really proud of whatever, it's really like my final project, for example, my capstone. There's no individual, oh, I got that 97. I'm so proud of that. Like, that high distinction or whatever it is, right? It was good. I mean, you might look at your GPA overall and say you were proud of it, but that's it. It's lived its life. It's become a piece of paper that you keep on your wall and you're done. So that's not to say that none of the university stuff you do isn't important. It's hella important. I'm just trying to give you context of things will change, your priorities will change. There are a lot of parallels to take, but there are a lot of things that are different, and you need to think much more on your feet, think more project, think more end result, learn to work with a team, be a sponge, learn how to talk with other engineers, learn, you're not in competition with these other engineers. You don't need to be. You lose your pride, no pride, and absorb. That's the fastest way I know to becoming, to improving as an engineer. With that being said, thank you so much for listening to today. This episode was brought to you as a question, as a question submitted to the podcast. So hopefully, more questions come in. I will answer them and I'll do a focus session. Remember to head to sariodev.com/engineeringirl. There's a form there where you can leave questions and I will do them on the show. If you get any value from this podcast, please remember to share it, like it, subscribe to it, let someone know. Share it with another engineer. And also, if you want to be part of it and you want to submit your question, what we're finding is that there's more and more episodes that I have queued up based on the questions. You can submit it at facebook.com/engineerirl. And the website now is coming up. So that's sariodev.com/engineeringirl. There's a form to submit your questions. And lastly, if you've listened this far into the podcast, just so you know, I will be doing a giveaway very, very soon. And the giveaway most likely will be the third book, which will be, it's like an engineering for kids book title. This is the first time I'm announcing it, but it's going to be really cool. The animations will be cool. And if you want to justify why you're an engineer, this is the one to have. I'll probably do something like, because I really want to reward the OGs that are listening to this. So it'll be, let's lock it in. It's the first 5 questions submitted through the form on the website. Those first 5 people will get a free copy of the book. Shh! Secret giveaway. Let's go. Do this.